Hello students, welcome to this session on column splicing. Splicing means joining. Joining of two columns, two steel columns together is known as column splicing. So many a times the sections which are available, they might be of shorter length. So we may require say a column of 8 meters and usual sections available are 6 meters. So I will have to join two members together and that is done by column splicing. So whenever column splicing is done, you have to take care of three type of forces. One is axial load, which is acting along the axis parallel to axis. Second is bending moment or moments acting on the section, and third is the horizontal force or shear. So my joint, my splice has to take care of all these three types. So let me draw a typical diagram and try to show how this splicing is done. Say this is one eye section. This is connected to another eye section. Say this is the top column, this is the bottom column. These are the flanges. When I take a top view, it looks something like this. It looks something like this. So here what I will do is I will connect flange of this to flange of this using a plate, and these are joined by some bolts. This is called as flange splice. Also I can connect web of this column to web of this using another plate, and again I will connect this by some bolts. So this is called as web splice. So I have to connect these two together. Now let us look at some of the specifications. So specifications are, first, we are assuming that the column splice is acting as a short column of lambda 0, slenderness 0. Hence FCD is taken as Fy by 1.1. So Fy is 250 divided by 1.1. So whatever is the value, directly you are considering that as FCD, and using this equation calculate area required. Second specification, whenever I have to provide flange splice, you have to provide flange splice of width. This flange splice is seen like this here. So this is the width of the flange splice, and this width of this flange splice should be equal to width of this eye section. So width of flange splice equal to width of flange of the eye section. Next, flange splice has to take care of axial loads, bending moments. Similarly, web splice is designed to take care of shear or horizontal force. Now fourth condition, in this case here, if the ends of the columns, they are milled, ends are milled or polished or smoothened, if I make these edges perfect, in that case what happens is 50% of the load from this flange is transferred to this flange by bearing action, by contact action, and another 50% is taken by these flange plates. Hence, when the ends are milled, polished or smooth or grinded, all means the same, or grinded, flange plate or flange splice is designed for 50% of loads. Next, whenever bending moments are given, convert bending moment into axial loads. Now that is done. Suppose this is the height h of the I section. Now axial load because of bending moment is equal to moment divided by h. M divided by h gives the axial load conversion of the bending moments. Next, sixth. So this is the case of equal columns joining together. Suppose we are having unequal columns. Suppose this is one column, another column. I want to connect these two unequal columns together. In that case, what is done is we provide a bearing plate. This plate is called as bearing plate. So whatever this load P is acting, so that P is acting through this flange and this flange. If this is P, P by 2, P by 2. Now here loads are transferred through the bearing plate. Next step will be select bolt dia, calculate bolt value, find out number of bolts required. Once you know bolt dia, you can find out edge and pitch. You can design the connection. So this is how the connections are made. Have a look at this diagram. This is the top column, this is the bottom column. There is a joint here. I have to connect them together. So this is the flange splice or flange plate which I am providing. This is the web plate. When I take a view in this direction, when I am looking in this direction, so this will look. This column, so I will see width B. This is height H. In this direction I will see width B. This edge, it is seen here. This edge is seen here. These edges, they are seen here. This joint is seen as dotted line inside the plate. Whatever this red line you are seeing, this is the flange splice, and these are the bolts. If you took a top view of this, so this black indicates I section, a flange plate on the flange, web plate on the web. This width of the flange plate should be equal to width of the I section. So this is a typical same size column connection. Now let us look at different size columns. So this is the case of two columns of different size. So this column is ISHB 300, this column is ISHB 350. So this dimension will be 350 and this will be 300. Hence, the flange of this column will not match with flange of this. So what is done is, on top of this bigger column, we put a bearing plate. Over that bearing plate, this top or smaller column rests. Now, some gap is created here because this dimension is 300 and this dimension is 350. So total 25 plus 25, 50 mm gap is created. This 25 mm gap is filled with a plate known as filler plate. So just the function of filler plate is to fill up the gap. Now here you cannot provide web splice because web of this is not connected to this, since there is a bearing plate in between this. Now let us try to take a look in this direction. When I am going to look in this direction, view in this direction, so I will see width B. This edge is seen here, this red edge is seen here, this blue for the filler plate, it is seen here. So these are the bolts. This dotted line indicates bearing plate, which is behind this web plate. So I am showing them a dotted line. So we'll be designing all the dimensions, thickness and number of bolts in the next classes. Thank you.